Hello, welcome everyone. We're just gonna wait for a minute for everybody to just tune in, and then we'll get started. It has been a fantastic day too, and I'm sure this session has been keeping you on toes. You want to tune in, so we'll wait for another 30 seconds for everybody to tune in, and then we'll get started. Great. So here we are. Welcome to day two of TestMu Conference, and what a fantastic day it has been. A great conglomeration of thought-provoking sessions. What a fantastic day to another round of everybody from community coming together and sharing how testing is really changing pivots to next level of orbits. This is Mohit Juneja, your host for this session, joining you all live from India. And let's get right into it then. And let me introduce the speaker for this amazing and insightful session on open mission control technologies. We have John Hill in the house. John Hill is a web UI test engineer currently working on one of the projects at NASA Research Center on the Viper mission's web based mission control software. With over 10 years of experience at a lot of technologies, and I'm going to name some of them from the days of Adobe Flash to the latest uh, JavaScript frameworks. John specializes in web automation, performance engineering, and test automation architecture. He's quite passionate about Jenkins, Ansible, and is currently an Open MCT enthusiast. He's going to explain about the Open End-to-End Test Initiative with Open Mission Control Technologies, also called as Open MCT. It's a next generation mission control framework for data visualization on mobile devices and desktops. Very, very insightful details coming your way, and it's all going to happen for the first time on this forum. He is here to explain how the Open MCT project can help the testing community write critical E2E tests using Playwright. So let's understand the who, what, why, and the how of open sourcing the test with John. Shall we? So let's welcome John on stage. John, take it away.
Great, thank you. So that's a great introduction. This saves me about 2 minutes of my presentation. So let's just hop right into it. Thanks everybody for joining today. So let's see if I can make this full screen. Yeah, so today we are here to talk about the Open End-to-End Testing Initiative with Open MCT. As you said, my name is John Hill. Just to summarize, I'm a web UI test engineer. I work for KBR out here in, I live in Palo Alto. The NASA Ames Research Center is in Mountain View, right next to Google. And I just recently joined as a Playwright ambassador. Super excited to share that with you all. Super excited to share some of the stuff I've learned by using Playwright for the past year and a half. So let's just dive right in. So as we talked about, today we're here to talk about Open MCT, and that's being used in the Viper mission, which is set to launch in the coming years to go to the South Pole of the moon to search the southern pole for water or evidence of water. It's a mission that's really exciting, and I encourage everyone to read more about it. And it's tangentially related to the Artemis project, and it's a really exciting project to be a part of. And part of what it'll be used in that project is the Open Mission Control project, available here on GitHub. So what I
John,
just did is took.
sorry to interrupt you, John, but if you're showcasing your slides, we're not able to see that. Let's just quickly check. Yes.
Absolutely. Yep. It was just a test, making sure everyone was
Fantastic.
fully aware. Yeah. So
Fully attentive here. Go on.
yeah, nothing.
Yeah.
Nothing. No one missed anything yet. Just this stock image available on NASA.gov. So yeah, you take this link to OpenMCT, and then at that point, you'll go straight to GitHub here. So here's the project. It's unassuming. It's the open mission control software. And just to read from it here, I don't work in sales, so I can't do a better job at this, but it's the next generation mission control framework for visualizing data both on desktop and mobile devices. So I'm sure we're all aware, the rapid changes in the industry, moving from kind of the thick clients installed on, you'll have like a Python app or a Java app installed with a binary. That's specific and packaged differently based off of Ubuntu, Mac or Windows or whatever. One of the powerful things that we've seen in the industry in general is the move towards the web, and the web itself allows basically mission control software to run anywhere. So you could run it on this laptop here, which is I'm about to show you, or you can pull this code down, run it for yourself. You can host it wherever you would need to go, and it's totally open source. Part of a larger initiative at NASA to move some source code into the open. Can't speak generally. I can speak to this specific project, but it allows you to basically visualize or give kind of insight into any sort of visualization that a mission control operator would need. I'm not going to spend too much more time talking about because I'm just to show you. But yeah, it's getting started is as simple as git clone, npm install, npm start by design. It's that simple to get going. But it can run anywhere. Chrome browsers, probably a Samsung refrigerator, although I haven't tried it. So let's, again, this is the Viper rover, a picture of it, just a stock image. But in this talk, super excited to talk about the Open MCT E2E test initiative. It's a mouthful. Again, I don't work in sales, so probably could use with some better marketing or something. But we're going to talk about that initiative, and we're just going to jump right into getting started with Playwright and Open MCT. We're going to talk about, spend some time talking about the challenges with end-to-end testing projects that are, I think, general, and maybe talk to specifically about how we solve them. And then talk to the things that are unique to this project, that are unique to what we're doing here, and then end with a call to action, kind of how you can get going. So and again, all of this, there's nothing to it. Anything that I'm about to show is is public domain and available on GitHub. So the goals of the Open ET test initiative are published here. So we're going to go to the discussion, and we're going to go to this here. And so I'm going to just summarize everything that's in this this discussion here on GitHub. If you're interested in contributing, this is where you'll start. So I encourage everyone to start here. But I'm going to kind of break it down into some slides to kind of structure this talk. But the goals, as outlined on that GitHub discussion, increase our test coverage. Obviously, so we're looking for the community to leverage the community to basically increase the test coverage for this product. So if you go back to the homepage, you'll see, we have a line coverage of 54, which isn't exactly precise, and we hopefully we'll have some time to talk about that. But you can see this is our coverage. This is our code coverage tool, and the idea is let's bump up those numbers. So we're really hoping that the community can help us and provide at the same time an opportunity for the general testing community to directly contribute to this NASA open source project. Again, I can't speak generally. I can say that this project is looking for open source contributions from testing, from the testing community. And hopefully, as a part of this is actually learn from the folks that do, contribute, to learn, to get something back from them, not just, coverage, but actually learn from, you're all testing experts at this point, and everyone would have something to learn. And I think this kind of speaks to kind of the problem with testing today is often when you go into an interview, even you don't have anything to demonstrate what you're capable of or what you have experience with. And so I've personally struggled to find other projects that allow me to do that. And this is a great time to do that. But also, we're going to talk about this specifically, ensure that Open MCT itself is accessible. The testing itself is accessible, not difficult to get going with. And I'll just show you just about how easy it is to get started. And just some history. The project itself already had a really healthy open source developer community of different people contributing applications. At the same time, there was already an existing open source contribution process, right? It's an open source project. You could already contribute to it, not with tests, but with development, and an existing contributor licensing agreement. All of that existed. So when I brought tests online July of last year, I very quickly realized that, that I wasn't going to be able to do it all myself, to kind of bring everything online. So not only do I work with the development team, but I also have already leveraged the community to kind of contribute. But this is the kind of the first time that I'm, being open about opening this up to a larger audience to hopefully get more contributions quicker. So like I said, that discussion gives you everything you need to know. Today, we're going to jump past step one, which is we leverage pretty heavily the official Playwright Getting Started documentation. That's kind of the barrier to entry. We can't obviously teach everyone how to use Playwright from scratch. And that team, the Playwright team, already has everything you need to know to get going. So what we're going to talk about today is kind of how you can get started with our implementation of Playwright. So let's just hop right in. So again, all of this is on the GitHub, nothing special. Let's just go ahead and hop in here. So the documentation, again, getting started, it's all right here in the source code. So I'm going to go ahead. I already have the source code downloaded here. So I've switched over to VS Code, and I'm inside the README. So what I'm going to do here is I'm going to follow through the documentation and getting started. Again, we recommend everyone run through the Playwright Getting Started guide. It's great. It gives you an exhaustive overview, and make sure you have everything installed, which is not not the responsibility of this project, right? To get going with all of the things you'll need. But we do ask you all read the development guide for getting started. It is literally that simple. Those 3 commands. I've already run them to save time. So I'm going to pull up a terminal window here, and I'm going to start following along. So let's see, I am going to run it locally. It's simply, I've already done the git install, the npm install and the git clone. So I'm going to do npm start, and I should have Open MCT running on 8080. So let's open up a Chrome browser and take a look. So refresh, and there we go. I'm going to delete the previous run. So starting from scratch, this is what you'll see when you pull this down. So in our getting started steps, I've basically outlined a way to kind of get familiar with OpenMCT itself and then replicate that with Playwright. So let's go ahead and create a display layout object and save it. So I'm going to hit the create button, and you can see a list of all the different things you can create. We're going to create a display layout, and we're going to call it something clever, demo display. Yeah, and I don't work in marketing. Okay, we're going to hit save, and we're going to save the object. Oop. Okay, so you saw what I did, created an object, hit save, and now the object is persisting both in the tree and is available here. So I'm next going to create a plot object. Again, one of the ways you can visualize data is through a plot. So I'm going to create the plot object, overlay plot, demo overlay plot. All right. That's saved successfully. And then we're going to finish editing. And then the last thing to do is create an example telemetry object, and we're going to pick a sine wave generator. So create sine wave generator. Okay. Here we go. So here's the sine wave generator. And if you look at the hierarchy here, here's the plot that contains a representation of that data, a sine wave generator, a perfectly unassuming, perfectly uninteresting one. Unfortunately, it's a sinusoid 1 to -1. But what you can see here is you can see this is a display layout, right? This is a display layout where somebody could create any representation of that data and organize it, orient it any kind of way that they need. And you can even do, you can clone it. So let's just take this one, clone it, and move this one here. So you can get a representation of that plot, both as a plot and then also as a table, to get a kind of a view of data as it comes across. And again, this is just for visualizing telemetry data. Save. And that's it. So just to summarize quickly what I've just demonstrated, it's Open MCT at its core. It's very quickly and visually creating these displays of telemetry data, and we include some example telemetry data for you to play around with. So the next step is let's do that in Playwright, and we're going to specifically use the Playwright Code Gen tool. So what I need to do is keep this running window started of npm run start. I've already installed Playwright Test, right, because I ran through the getting started guide, right? So I already have everything I need. So I'm going to do an npx Playwright Code Gen in a separate terminal. Npx Playwright Code Gen. And what we're about to see happen is Playwright is going to launch 2 windows. And I apologize, there's no real way of making this bigger. So I'll do my best to kind of describe what's happening. But on the right is the inspector, on the left is the window. So we're going to basically just replicate what we just did. Go to localhost 8080, right? And we're recording everything that's happening on the right. So you can see I hover over this button called create, and that's been saved here. Then I'm going to go to the display layout, right? And select this demo display layout. Okay, created that. And I'm basically just capturing everything as it happened earlier, but I'm capturing it as Playwright code on the right. So this is record and playback, which is what we're all familiar with, I think, from various projects and various attempts over time. And so let me just go ahead and finish this. I'm going to make this last thing just to prove that it works. Okay, and we've done it. Now let's go over here and view that object. There we go. So and that's it. Basically what I've done is I've captured everything that a mission control operator would do to create this layout. And I've basically recorded it as a series of record and playback steps. So I'm going to copy this code, and I'm going to take it and put it into here. And so what you could do is, take it and dump it and put it into here. And unfortunately, I do need to change one thing about this. So I'm just going to leave this alone. I had to change the import statements just because of the kind of the nature of this test. So what we're going to do is run that same test, but we're going to run that as a script. So so if I were to copy that into that file, that's what this would look like. So I'm going to go ahead and stop that code gen and do npm run test E2E local. And because I've added the .only decorator, it's only going to run this one test. And let's watch it go. So create the object, put it in, and then go back. And that's it. Kind of, so that's taking that script that we just wrote and turning it into, and it's something that can be run as a part of, CI or whatever, which is awesome. So what I'm going to, and it kind of speaks to some of the capabilities of Playwright. So what I'm going to show you next is what we ask folks to do next. So close any terminals which are serving up a local instance. So that was the one we have back here. And then we're going to go into and run this statement. So this is similar to what we just did. The only difference is, that's an odd copy. We're going to do npm run test et local, specify a given test. That reminds me, I need to remove this .only. Okay. And then, oh dear, I've lost it. Oh, here it is. We're going to just run this one test called example template, and we're going to run it in debug mode, right? So while that's starting, that's going to initialize the web server and control it. So instead of you having to manage your own npm run start, it's actually going to run it and then provide some health checks to make sure it's actually available and you're actually available to start, working with it. But what we're going to do is we're going to go into this example template directory, and we're looking at this template file. So inside of here, what we're hoping to capture, and okay, so the test has gotten ready in debug mode, is kind of the best practices for the project. So as we've been using Playwright over the past year or so, we've learned more and more about it. We've learned more about our application of it, and we've needed to kind of test and reinforce that as it changes over time, just so that we, as new people come on from the development team or the open source, that they have a place to begin. So what you'll see here is you'll see a very a heavily documented version of a test. In this case, we're just creating a timer object. So instead of a display layout, we're creating a timer. And I just want to call out a few things here. In fact, actually, let me just go ahead and go back into the background. So in the backgrounds, you'll see that same inspector, right? But what you'll see, instead of a kind of a recording session, you'll see this test in the back available to run. So I'm going to run through this test in the back. And you can see as I step through, right, you can see the test running and kind of demoing some of the core functionality that we would want everyone to become familiar with. So one thing I want to call out while this is running, let's see if I can get to the given form, is this explore button allows you to kind of take over and then see all the available selectors that are available. In this case, we have the text area type text. We have, these sorts of things, but what you'll see is you'll see references to roles and you'll see references to ARIA. And I just want you to keep that in mind. Otherwise, there's actually nothing all that interesting about this test. But in the test code, I just want to call out three very specific things. We extend the base functionality of Playwright in all of our tests. So all of our tests generate code coverage. All of our tests check for console errors that are being thrown, and then fail the test when those are thrown and capture those. That's a problem that we've kind of had in all of the ways that these tests are used. There's other functionality, but those are the main two that we've added. Those are not built in to the core of Playwright, but that's something that we've put a thin veneer on top. So all of our tests will use that, and all of those and all of everything you need to do that is already baked in if you just import tests and expect this way. And the other thing to call out is we've added helper functions here in app actions. And so if you hover over in VS Code, the Playwright APIs page go to, you'll get a really good representation of how that API can be used and kind of the expectations of that. And even like a direct link out to go to their documentation, which is first class and which is great. But at the same time, we've added that ourselves. So all of our functions that we provide, when used, give you a reference of how to use it. So create domain objects shows you kind of how you would be expected to use it and what it does and what it returns. So it's very easy to kind of use these very complex functions and both have examples of them, but also have a pretty clear documentation of how they should be used. And then the last thing I want to call out here is test.fixme. So if you look at test.fixme, this is a decorator for skip that allows us to address and isolate tests that do not yet exist. And we refer to those as stubs. And that's kind of the crux of this project right now. So right now we have littered the code base with stubs of tests that we just haven't had time to write. And what we've done is we've documented them, put them in place, and also provided BDD style create a domain object, copy this object, delete this object, and expect copied object to persist. This is kind of how the test would work if someone were to pick this up and do that. And so really what we're hoping to do, and what we've had success with, is the community coming in and filling in this boilerplate code and making this test work. So that's the third thing I wanted to call out. So what I'm going to do here is take this second test, and I'm going to break the locator, which is something, as testers, we're very familiar with, right? The locator changed. In this case, the class name changed. And we really shouldn't be using the class name for this, but, here we are. So I'm going to run that same test. Actually, I'm going to do that without debug and just run it as if we were running it in CI, or running it as if we're running it all the way through locally. So again, it's launching the web server and instantiating Open MCT on localhost using npm start, then doing a series of health checks until it's actually ready for the test to begin. And Playwright manages that for us. Fortunately, it doesn't make a good demo because it is kind of slow. There we go. Okay, so the test has started. And now it is going to run all the way through. And then here's the second test that we modified. It's going to run all the way through and then stop. And the reason it stops is because of the locator changed, right? Something about this changed. And what happened is the test stopped and started the HTML reporter that gives you a pretty clear understanding of the error, right? It says it could not find this object here on this locator. So that's the change we made. That's the change we made in time, right? And then here's a screenshot of where it got before it failed. And then the most important thing is the trace file. So when you open up the trace file, I'll make a full screen. And again, it's not really designed. I'll make it a little bit bigger. It's not really designed for, demonstrating in this way, but you can see the list of actions as they occurred on the left, right? And then you can see what the application looked like before and after that step was performed, and the source code of that step being performed. And here we can see the failure, right? This is where it failed. It failed to find this locator, right? It failed to find the locator called 𝑙_browser bar object name 2 because we broke the test effectively. And importantly, I just want to call out, this is not a screenshot. This is actually a snapshot of the DOM in time. And so you can go back and look at the DOM to see what that was actually called. In this case, it was not called 𝑙_browse bar object name. It was called 2. It was called 𝑙_browse bar object name 1. Suffix. So that's an example of how you can use the available tooling to kind of isolate failure and triage very quickly. This running against Open MCT. So let me go ahead and stop that. And I'm going to go back to our presentation here and just kind of summarize what we just did. So let me put this back into full screen for everybody. We utilize Playwright to mimic mission control operator behavior to interact with Open MCT, exactly as a mission control operator would, right? They would physically click on these buttons to generate that display layout that would mean something to them. And we use Playwright to just kind of record and play back that happening. And then also demoed how easy it is to start writing with the CodeGen tool, and how easy it is to debug tests with the debug flag. You can step through each test and watch it running live. We also talked about how OpenMCT reinforces our internal evolving best practices into the onboarding process. We have everyone go through this and kind of see how our example template is used and show how, as things change, how we want the best version of new test suites to be used. So the idea is every time we update our framework, we want to update the example template and then use that in the next suite to kind of keep us moving. We also showed test stubs and 𝒃𝒐𝒏𝒄𝒆, kind of how they coexist in a test suite, so you have enough context to kind of get going. And we invoked failure and utilized the existing triage tooling to understand exactly what went wrong. So that's kind of it. So that's kind of getting started. And going from 0 to 1 would involve modifying, that third test to make it work, right? And we have enough to kind of get people from 0 to 1. So what to contribute? That stub is what we, right now in this stage of the project, what we're really hoping to have folks help us with. And we already have had a lot of folks help us with. And these kind of come from the Open MCT dev team, both with our kind of understanding of what's going to be rewritten, refactored, or replaced or deleted, and also kind of the severity of bugs as they come in. We can help kind of keep track of these. So bugs and enhancement with a little bit of hidden knowledge about what is actually going to get, certain plugins, for example, are going to get deleted. So we wouldn't want people just to hop in there and start writing something for a plugin that gets deleted, like maybe I did when I first joined. first plugin I automated a test for was deleted. What are the odds? Okay, so next, let's just talk about the general challenges with any end-to-end project. Onboarding. That's huge, and that's really what we're talking about. How to get from 0 to 1. So somebody new hire, getting started, know nothing about even the application, how to get them to 1. So we've our solution is to reinforce an example template, provide linting and enforcement, and as much self-documenting code to kind of get people very quickly up and going. I don't know yet of any other way to get people through faster without actually doing this kind of synchronously. The second thing that we can't talk about today, we just don't have enough time, is our test promotion process. How that one test goes into the nightly, goes into the mainline build. That we just don't have enough time to talk about. But that's one thing we've done. We've broken down getting from 0 to 1, and that one test getting into our overall pipeline. That's done through a test promotion process. The next thing, I think, for those of you that are maybe have been a sole tester on a general front-end team, you may have experienced this, but generally JavaScript web devs will focus on the clever, elegant, and concise implementation of tests and test framework, and which is great because that gives us a lot to learn from. For those of us that are testers, working with these folks that have a deep understanding of the web and JavaScript. But really, I think I can speak generally and broadly that QA is actually more interested in saving 3 hours in triage time than we are on saving 3 lines of code. I think we can generally agree that that's how we orient our time. We expect failure, we anticipate failure, and we want failure to be more clear. So our solution is, despite all of the improvements that we make to fixtures, to generalizing functions and all that kind of stuff, failure must be obvious in that trace file and in error logs. So that's kind of how we keep this tight, this churn and tussle between having great access to web development and best practices, while also making sure that we kind of keep everybody on the same page. Next, I want to talk about some of the unique opportunities and challenges. Our open source tests are reused in downstream projects. So that example test suite needs to run against closed source projects that are obviously not targeting local host. That's what makes this challenge unique. So we need to have more abstraction about the assumption of, right, the orientation of things in the tree, right? Or even one of the things you saw is this test started with nothing, but that's because it's using local storage instead of a persistent database, which is not one of the ways that this Open MCT can be used. So the more abstraction and the fewer assumptions we bake into the test, the more likely they can be reused in all the different downstream projects. And one of the big ones is we don't have page objects. Page objects is a great way of abstracting away, the test code version of the application, so that the tests are very easy to fix when they fail, or if locators change, or that sort of thing. But we have another solution called App Actions, and we're going to talk about it on the next slide. And the other big thing that comes with being this open and closed source thing is effectively a lot of our tests actually become contracts. So many of you are probably familiar with Pact. Um, and so Pact is a great way for APIs to provide a standard interface between two different microservices working with one another, or two different providers sharing kind of the same schema. Well, we need something similar. So a lot of our, like all of our performance tests right now have no assertions. They just serve kind of as contracts so that the dev team can make rapid improvements to the application without breaking our downstream performance tests. They every commit, every PR, everything needs to pass, and so we're very aware of when the UI front end tests change, and then we can make the if any changes are needed on the performance test, we can make them. Another unique challenge is dev and test me. All of that time is shared. So there's not dedicated QA time. There's not dedicated build time or release time or any of that stuff. It's all kind of the shared pool. And what that ultimately has resulted in, and it's easier to make the case to make the application more testable, right? So we all move as fast as, I can write tests. So the more testable the application is, the more likely it is to add exhaustive coverage quicker. So that's kind of the unique things. And the unique thing that also applies here is this. As I talk about this, one of the problems that it happens, and I've worked for the Jenkins project, Ansible, and now Open MCT. One of the problems you have are kind of like these drive-bys of people just trying to make a change to get that GitHub badge or whatever on their thing. We literally cannot afford people to restructure the order of imports. Like we can't have that. If you're interested in contributing, we do actually need help and encourage folks to help us add coverage. We don't need people to reorder import statements. So one of the things I need to talk about. So for those of you that are interested, if I've sold you on this, or if I haven't yet, maybe this is one thing. So app actions and accessibility. So we have no common DOM, therefore we have no common POM. Page object models is great in modeling the application. However, we don't know exactly what plugins people are going to use, how they're going to use them when they source Open MCT, and if they're going to reuse our tests, right, in the various projects that reuse them. We can't rely on the page object model. So what we've done is, and I've done this in my past, but we're going, all in on this, is the app action pattern, which combines repeated user behavior and turns that into a common function, not a fixture. A common series of steps, like creating something from that drop-down list, is an app action, and the result is the object that you wanted with the default things. That's an example. And so instead of investing in a page object pattern and all of that sort of stuff, what we're actually investing in is leveraging accessibility friendly locators, and that comes in the form of ARIA and roles that are leveraged by screen readers. So I called it out where I could use the explore thing to kind of show you the various selectors. So at the same time that we write tests on the development team, we're actually making the tests a locator logic easier for screen readers and also Playwright. I don't know if you went to the Chrome DevTool recorder talk yesterday, but that's actually the preferred way of capturing all of those steps. So the Chrome DevTool team, the number one way, the first available selector or locator is, right, not CSS, not XPath, not data test ID. It is the web accessibility standard. So this, I think, is fairly recent, but it basically boils down to the time. If dev and test time is shared, if you only had an hour, where would you spend that time? Would you make it and to make it more testable, would you add a page object model which perfectly mirrors the application, or would you just make sure that your application is more accessible and easier to work with all of the available automated tools that are coming, specifically Playwright and the Chrome DevTool team? So that's kind of our, if you're wondering and you're walking through why things are the way they are, that's kind of why. So I'm going to end it here with a call to action. I want you to open source. That's kind of the directive here. And this is just one of the contributors wrote this to us after he finished. He basically learned about Playwright by doing this, by contributing to this, and actually brought it to his employer, and they made the switch to Playwright. And now he writes in an old day. And secretly, selfishly, I hope that this person contributes back after he brings all of this is actually to make our shared understanding of open source testing better. So hopefully his employer gives him the time to add back and start contributing more tests now that he's added some. So in summary, we talked about the initiative, showed you, we did not showed you, we literally did it together, getting started with Playwright and Open MCT. We talked about the challenges that are part of any end-to-end project, and specifically how we solved them. But I'm encouraged to learn about maybe how other people have solved them. We talked about the unique challenges to this project, and hopefully convinced you in a call to action. So that's it. I'm available to answer any questions that are on the line, or talk to anything that any questions you might all have.
What an insightful session, John, and you have really gotten the right code up and running here. So many questions. We'll take some of them. Let's start with the first one here. How can one go about contributing plugins to Open MCT? Ask Amanda. John?
Hi, Amanda. Yeah, so that, as I said, this project's been around for a while. In fact, if you go to the website and you go here and you look at the lead designer is going to kill me if he sees this, but you can see this demo hosted on Heroku is like 5 years old. So it's been around for a while. So the process for contributing plugins is actually pretty well established, and I can and it's available on the site to. On how to do that specifically. If you're looking to contribute plugins, like one of the plugins I saw is, for those of you who may be familiar, the Kerbal Space Program has, that video game has a plugin for OpenMCT, so you can visualize the video game data in a display layout, just like we did. So kind of cool.
Fantastic. Let's take a couple of more questions, John. Very interesting questions out here. So the next one is, are there any plans to use TypeScript versus JavaScript? What are your insights, John?
I'm not allowed to speak to, literally I'm not allowed to speak to like any sort of commitments, right? I'm not allowed to. But I will say, what you just saw are typings built in to our tests. And so we are using TypeScript hints and some typing sporadically throughout the application. So when working with certain APIs, you will find typing hints. I cannot say if there's a plan to go totally over to TypeScript. I literally can't. So sorry.
That's great. That's great. I think another interesting one, and you explained end-to-end tests and how to adopt it, can be automate end-to-end tests using APIs. Ask Manish.
Yeah, absolutely. Let me show you really quick. So if you go back to the code base here, we just added this week or last week. So we added a GitHub action for CouchDB. CouchDB is our persistent data store. So what we have is we have this GitHub action that stands up a containerized version of CouchDB, a persistent data store. And then inside of our test code, we have a new suite of tests, functional, couch. So yeah, so we automate API tests as coming to and from our persistent data store, and we provide examples of how you would do that. So there's two things to say about that. There's two APIs. There's kind of the real-time stuff going on that share the browser context, which includes like the token authentication and stuff, and it's as if it's coming from the browser. And then they also provide a direct line of API requests to and from the node process that's running with no authentication. So it's not. So there's two ways of using APIs. There's APIs from the browser being triggered, and there's also APIs from the node process being triggered. So so in our case, we actually use both. And unfortunately, in the open source, we don't have best example of this, but this is one way we would do that. So in our case, we need to we have a series of things that'll happen if the database goes offline, right? And you can see that. Let me make this bigger. Sorry. If the database goes offline, we want the application to be able to handle that. And so when that happens, we would throw this to screen. So what we're able to do is mock out different traffic patterns. And the next step is actually to do hardcore, full-on resiliency tests, which are restart the database container and validate that without mocking out the API, that it does show offline and that it recovers gracefully, right? So that's hopefully that, I think that answered your question. But yeah, so that's what we have. And again, everything is open source, so we encourage everyone to take a dive in there and take a look.
Fantastic. What a power-packed session, John. We are on top of the hour. There are too many questions, but I think great insights. You've already covered a lot of questions which you have not asked. Fantastic. I'll just repeat the call to action that you gave to everybody. Let's contribute more to open source. Let's create a better, brighter future together. Looking forward to more such conversations on TestMu Conference. John, thanks a lot for giving us time and really sharing these insights with all of our audience.
Thank you. Yeah, thanks everybody for attending. Glad to be a part of this community.
Fantastic. Thank you, everyone. Stay tuned, and we'll see you again.